Okay, let's take a look at this problem that we worked out. We actually did everything that we were supposed to, but we didn't put it together in the end the right way. So let me show you. Let me get my pen. Okay, so we're going to take this inequality, x plus 5 over x minus 2 is greater than 3. All right, so if you remember the steps that we went through, we first look at the denominator and determine where x minus 2 would equal to 0. If we solve that, we're going to add 2 to both sides. You just did it in your head because you had enough practice with these types of equations, I believe, to just do it in your head. So when x is equal to 2 and you plug it in here, 2 minus 2 is 0. So that's going to be one of the areas where the solution is not going to work. Okay, so that's what goes here. Now for the numerator, it's going to be a little bit different. We're going to go ahead and I'm going to move to the bottom. We're going to follow through with the work that we did together. X plus 5 over x minus 2 is greater than 3. So what you did correctly is move the 3 over to the left to get it together with this fraction, x plus 5 over x minus 2 minus 3 is greater than 0. Okay. So then, if you remember, we did all these steps together and we did them correctly because I went back and looked. We multiplied both of these terms by that denominator x minus 2 so that we would not have fractions in our inequality. Okay, I went ahead and put that over 1 so you could see how this cancels out. The x minus 2 is the denominator. So here we're going to bring that down as x plus 5. And then I'm going to distribute a negative 3 to the x in that binomial and the negative 2 in that binomial. So negative 3 times x, and I'm going to put plus and write that as a negative 3. You could write it as minus, but I like to keep my signs with my terms. And then negative 3 times a negative 2 is a positive 6, and that's going to be greater than 0. All right, now let's combine like terms, and we get 11 as our constant, and negative 3x plus 1x is a negative 2x. And if you remember, we got that, and then we divided by a negative 2. And then when we divide by a negative 2, this inequality is going to flip, and we get this cancels out, and I'm going to move over to the right, put my answer here. We get x for that first term, and when I divide 11 by 2, I get 5.5 or 5.5 is greater than 0. Now if we do the same thing for this, when would that equal to 0? If we had a negative 5.5. Oh, I forgot to, because I divided, I forgot we're dividing by a negative 2. Let me go back. I went too fast. When we divide the 11 by the negative 2, that's a negative 5.5. And this is going to flip around. But what we're considering is where that becomes 0, or where that is equal to 0. So x minus 5.5 equal 0. When we solve for x, we get x equals 5.5. That's going to be another location that we're going to have to circle and actually omit from our answer. So it's going to be an open circle. So that's where we got those two numbers, 2 and 5.5. You put the smallest one first and then the next one. So that's going to determine on our number line where those intervals are. And we're going to circle those numbers, and then we're going to check values here, here, here in our equation to see where those numbers make true statements. And then we're going to shade either in the area between or the areas to the right and to the left.